So if you want to take a look at your number 8, kind of compare it to what Julia has. The answers were sent through Remind on Friday. So I just kind of remind you, make sure you are checking your answers through Remind or Google Classroom. Everything is posted to one of those sites, or check in the back of the book if it's a work or a book assignment.
Okay, I had number 8, which was y equals 2 parentheses x plus 2 squared minus 4. When you go back to the base equations, which is y equals a parentheses x minus h squared plus k, and then the vertex base equation is hk, and then the axis of symmetry, or AOS, is h. The equation y equals 2 parentheses x plus 2 squared minus 4, when compared to the base equation, you get a equals 2, h equals negative 2, and k equals negative 4. H is negative 2 even though it's positive in the equation. It's the opposite of the sign. When you look for the y-intercept, you have to set x to 0 because y-intercept is when x is 0. When you do that, you get y equals 2 parentheses 0 plus 2 squared minus 4. When you go to solve it and you subtract you add the 2 to 0, you get y equals 2 parentheses 2 squared minus 4. When you square 2, you get 4, so now you have y equals 2 parentheses 4 minus 4. When you multiply 2 and 4 together, you get 8. So now you're down to y equals 8 minus 4, and that is 4, so your y-intercept is 0, 4. So now you go back to your vertex. The vertex base equation is hk, and h is negative 2 and k is negative 4. Therefore, the vertex is negative 2, negative 4. And the axis of symmetry is also h. So you have your axis of symmetry, which is x, is negative 2. And then this is the graph when you graph it.
So I'm going to go over number 15, talk about that one with you. So if you want to turn to number 15. Number 15 kind of looked a little different. This was set up in intercept form. Except looking at 14 and kind of looking at 15, there's only one set of parentheses for 15 instead of 2. But there still are 2 x-intercepts in the problem. So intercept form is when we have those 2 parentheses, and the numbers in the parentheses usually give us the x-intercepts. So if you look at number 15, when it's in intercept form, the first thing we need to list will be the x-intercepts. Can anybody give me one of the x-intercepts for number 15? So Rebecca said negative 7, because right here you're taking the opposite of that value. So negative 7, 0 is one x-intercept. It's the opposite of the number inside the parentheses. But there's a second one, because they're supposed to have 2 x-intercepts, and there will always be 2, unless the x-intercept happens to just be the only point on the parabola that it's kind of touching at the x-axis. Does anybody know where the other x-intercept is? Abby?
0, 0.
And why is it at 0, 0?
Because there isn't another equation.
Yeah, so that x, the second x value, if you look above at number 14 says x minus 1 and x minus 4. This x is really x minus 0, except we don't write x minus 0. So if there's not a number with x, it's not moving that x value left or right, but there's still an x-intercept with it. So like number 14, you have those 2 numbers that are written with the x value, In number 15, you just have the 1, but there is a second x-intercept, and that would be at 0, 0. So negative 7, 0, and then 0, 0. So those would be our intercepts. The next thing we need to find is the axis of symmetry, which means you take those two x-intercepts and you add those together. You divide them by 2 because the axis of symmetry should be directly in the middle of them. So we have negative 7 plus 0 divided by 2 is negative 7/2, or you could say negative 3.5. Make sure you're keeping that as x equals. On your homework that I passed back, I probably have AOS x equals. It is a vertical line. A vertical line is an x equals form. That's what creates a vertical line. So make sure you have that as x equals. And then the other part that we were asked to find would be the vertex. How do you find the vertex once you have the axis of symmetry? Gavin, how do you get the vertex if we know the axis of symmetry? Yeah, plug x in. So in the original equation, we have negative 3, and then x is negative 3.5. And then we have x plus 7, well, negative 3.5 plus 7. So we're taking negative 3 times negative 3.5 times positive 3.5. And does anybody have that number? Mackenzie.
36.75.
Thank you. So our axis of symmetry was negative 3.5, the vertex 36.75 for the y value. So graphing that one, because it's such a large number, is a little more difficult. And they counted by 6 on the graph, so that's why it looks like that, counting by 6. Good morning, Mr. Cummings. So you see on your y-axis it's going by 6s, the x-axis is going by 3s. The reason it's doing that is for the values that were given in your vertex. Any questions with number 15? Okay, so I want to go through those 3 different graphs with you. Keep your homework out if I didn't get to you, so like the last 3 rows here, I did not get to you guys. So just keep your homework out. I will come around in a couple of minutes. So please keep that homework out on the side of your desk so I can come around and check it. So tomorrow quiz. The quiz is on the 3 different types of graphing, meaning the 3 forms a parabola can be given in, and approaching the graphing based off of those 3 forms. There will also be a word problem or 2 on it, and I have a little review for us to work on so you can kind of get an idea as to what information will be on the quiz. It's a 25-point quiz. It's just front back, I believe, and it might go into like half of a 3rd page, but only because it has graphs and the problems are kind of spaced out to give you some room. So if you look at the first form, we have 2x squared plus 4x minus 1. Does anybody know what the numbers here stand for? Like what type of problem is this when you have 2x squared plus 4x minus 1? Gavin? Yeah, excellent. This is standard form. Never. Okay. So this is considered standard form. And when you have standard form, we have ax squared bx plus c. So that's standard form. When it's in standard form, we have a little formula to find the axis of symmetry, and that's the first thing that we would want to find. Does anybody know what the axis of symmetry would be? How do you find it? So what's the little formula we use? Emma? Yeah, negative b divided by 2a. So standard form uses the little formula with negative b divided by 2a. Those letters are in the problem. The numbers represent the a and the b values. So negative b would be negative 4. And a is positive 2, so Emma, negative 4 divided by 4 is negative 1. So the axis of symmetry is at negative 1. That's the line that cuts our graph in The next thing we would want to find would be the vertex. And the axis of symmetry is always the x value of the vertex, no matter what form we're in. So when you have the axis of symmetry, it's also the x value of the vertex. And just like we did for the previous problem, once you know x, you plug x in to find y. So working through, -1 squared is +1. And then we have 2 times +1 minus 4, and then minus 1. So Emma, the y value of the vertex is -3. So the vertex, -1, -3. Make sure you're rating the vertex as an ordered pair. And then the last piece of information we can calculate here is the y-intercept. What number is the y-intercept when it's in standard form? Shouldn't have to do any work. Kenzie Myers, what number is the y-intercept in standard form?
So 0C.
Yeah, it's 0, c, so in this case, it's a -1. Again, make sure you're rating that as an ordered pair. So it's a y-intercept because the x value is 0. It's on the y-axis. So standard form, ax squared plus bx plus c. We now have all the information we need to make a little sketch of this. So at -1, we have our axis of symmetry. On a -1, we also have a vertex down at -3. And then the y-intercept is at 0, -1 on the y-axis. Using symmetry, you can model that same point on the other side of the line. So if I would be 1 to the right, I would also have to be 1 to the left of the line. How do you know this graph should open up? Like a way just to kind of give yourself a quick check. My graph opens up, but what part of the equation tells that, Julian?
A is above 0.
Yes, so the a value is greater than 0, and because it's positive, it's going up. So just a way to check yourself. That a value should match the direction that your graph opens. Questions with the standard form? Okay, so if you look in the middle, the second form that we have here is called vertex form. And it's considered vertex form because we have a, x minus h squared, and then plus k. So pretty much the letters in each type of problem represents a part of that problem. So since it's in vertex form, without doing any work, we should be able to find the vertex. So Brandon, what's the vertex of this problem? Say it again, 1, 2, yeah. I thought you said 0 at first. So the h value is the vertex, and the k value. Those two letters or numbers paired together make our vertex. And again, it's the opposite of h. So it's not that minus that goes along with the 1, it's just the 1. And then the k value. Brandon, the axis of symmetry is?
1.
Yeah. So it's x equals h. Well, the h value is 1 in the vertex, so that same value is the axis of symmetry. And then the last part we need to look at is getting the y-intercept. Brendan, how do you find a y-intercept when it's in vertex form? Yeah. So we have a -3, plugging 0 in for x, because our goal is to have 0, comma, some kind of number, whatever that number happens to be when we calculate it. So this is the work that you need to have for intercept form. You gotta have a little work, or I'm sorry, for vertex form, a little work to find the y-intercept. So here we would have -1 squared, which is +1. And then -3 plus 2 is -1. So we have an axis of symmetry at 1, the vertex at 1, 2, and then the y-intercept at 0 and negative 1. All the graphs are created the same exact way. You're just finding the information a little different based off of the way the problem is written. So the form of the problem kind of helps us find that information. Eden, do you have a question? You were just stretching. Okay. And then again, using symmetry, if I'm 1 to the left of the line of symmetry, I should be 1 to the right as well for that y-intercept. So vertical line at x equals 1 for the axis of symmetry. The vertex is up at 1, 2. And then our y-intercept is down at 0, negative 1. And a quick check just before you kind of move on, make sure your graph is correct. The number in front is less than 0 this time. Since a is less than 0, our graph should go down. Our graph does go down. So if you have a graph facing the opposite direction of what it should be, then somewhere you made a miscalculation. Questions? Okay, so the last type would be intercept form. This one still has that a value in front, but it gives us the intercepts, and we call those p and q. So Will, what would the intercepts be in this problem?
1 and 7.
Nice, so 1, 0, and 7, 0. So you're taking the opposite of those numbers inside the parentheses. Again, the minus sign is separate. Will, what are the intercepts? Help us find.
The axis of symmetry.
And how would you find the axis of symmetry?
P plus 2 divided by 2.
Nice. So 1 plus 7 divided by 2, Will, is? Nice. So the intercepts help us get the middle value of the axis of symmetry. Symmetry means it should be in the middle of any two pair of points. So if I have two x values on the x-axis, then the symmetry should be in between them. And we can take those values, cut them in half, and you get the axis of symmetry is 4. And then to get the vertex, again, in every single one of these problems, the axis of symmetry is the x in the vertex. So you take that x value and you plug it back into the original problem. So we would have 4 minus 1 and 4 minus 7. So we're looking at 3 and a negative 3, which makes negative 9, but there's a negative 9 or negative number in front of it, so that gives us a positive 9. So going to positive 4, we've got that axis of symmetry, which should be in between our 2 points of 1, 0 and 7, 0. So symmetry means things should be symmetrical. So those 2 points need to be in the middle of our line. And then up on that line, up at 9, so graph goes down because there was a negative in front of the original problem. That a value is negative 1. Questions? So that gives you like a little study guide as to what to look at. You've got one of each type of problem so that you can kind of use it as a reference when you're working through some problems today. So I have a worksheet to give you that goes over the graphing. I'll pass out graph paper in a minute. But you'll see that it's kind of set up like each problem is a part of the worksheet, so I have divided them into separate parts. And then I tried to put in a couple of different types of problems for each type that we've looked at. And then I have some word problems as well. I also have an answer key that I will send out to you. Again, keep your homework on the side of your desk if I didn't come around and check it. I will be around. And I got one more thing, I got graph paper to hand out to you. Sorry for the separate pieces of paper. So a stapler should be coming around. Two of them are kind of working their way around the room. Feel free to grab a partner. You have like 15, 16 minutes. Please work. Use this time wisely. Get a lot of this done. Ask questions if you have them. And again, for the 3 rows on the one side of the room here, I'll come around and check the homework. Wherever you're sitting, I'll get it from you.